Good afternoon, everyone. Welcome to Computational University. My name is Hee-Jin Kim, and I'm a professor in the Department of English here at Computational University. It is my great honor to introduce today's distinguished speaker, Professor Christof Schöch, who will be presenting on comparing, evaluating measures of keyness or distinctiveness in computational literary studies. This special lecture is part of 2024 BK21 fall program, and it's taking place at Computational University. Professor Schöch is a prominent figure in the field of digital humanities. He is currently a professor of digital humanities at the University of Trier in Germany and serves as the scientific co-director of the Trier Center for Digital Humanities. His academic journey began with studies in Romance languages, English, and psychology at the universities of Freiburg and Tours, culminating in a PhD in French literature from a foundational program between the University of Kassel and Karlsruhe. Professor Schöch's research lies at the intersection of French literary studies and digital humanities. His work focuses on computational literary studies, particularly the use of quantitative and statistical methods for text analysis. He has extensively explored the topics such as the digital humanities, open science, and the modern and contemporary law. His contributions to the field are reflected into numerous publications and his involvement in various prestigious committees and research groups. In addition to his academic roles, Professor Schöch has held significant positions within several professional organizations. He is the president of the Alliance for Digital Humanities Organization, ADHO, and a vice president of the Digital Humanities Association for the German-speaking area. His dedication to advancing the field is also evident in his editorial role for the Journal of the Computational Literary Studies. Please join me in welcoming Professor Christof Schöch.
Let's start. First of all, I would like to thank a couple of people who made this event possible. The two colleagues, Sujin Kang and Hee-Jin Kim of Computational University here, and she's somewhere there. Yes, thanks a lot. And also KADH, the Korean Association for Digital Humanities. The DFB is the German research funding body, national research funding body, who funded two projects that I will report on today, or on the research we did, I will report on today. And of course, on the right, you see the project team of these two projects that have actually done the actual work, while I have, come up with the idea and coordinated the work, but they are the main protagonists. So, this is the plan for today's lecture. I want to explain, first of all, what keyness is. So, what this concept really is. Introduce you to the concept, and then also talk a little bit about definitions of it. I want to speak a little bit about the history of using measures of keyness in computational literary studies, and then show you how we did some methodological work on evaluating these measures on different tasks, quantitative evaluation, but also qualitative evaluation, so statistical and also, let's say, less statistical, a bit more on the content side of things before I will conclude. So you can already gather that this lecture is at the intersection of linguistics, statistics, and literary studies, and so it's interdisciplinary work. And that is also why the team that worked on this is composed of people with different backgrounds. And we're trying to bridge these fields to some extent. But so let's see, what is keyness all about? And you see the type of comparisons. So keyness is, keyness measures are findings from my work in computational literary studies first. For example, I found that the average sentence length in English language novels in the period 1920 to 1939 is 80.9 words. If you look at adventure novels by Arthur Conan Doyle, the hunting topic modeling, the hunting topic has a probability of 0.38. Okay. And the third finding, the average word frequency of the word et, which means and in French, in French crime fiction or en liste blanc, is 2.65. So you would say, okay, so what does it mean? And you're right, obviously, to say, okay, this is not a finding. These are just some numbers. And why are they just some numbers? Because we don't know the scale. We have no comparison. So any value, any number that they calculate only gets meaning by comparison, in context. And of course, these are completely meaningless. And I'm sorry to have played a practical joke on you in a way of presenting this as findings. But of course, they do make sense if you present them in a slightly different way. So here, for example, you see the distributions of sentence length in 2 time periods. And you can see the blue density curve shows, has a median of 18.9, and that's the later period. And then the earlier period. And then the orange one represents the later period. And even though the spike is higher, it shows that the median is actually lower. So sentences get shorter over time. And only when we compare 2 time periods and the values for these time periods do these values really make sense. So 18.9 is actually low because before it was 31. Okay, so it went down quite dramatically. So in comparison, the values start to make sense. Now, if you compare this value to the even later one, it might be even shorter. Short sentences continue to be shorter over time. So if you compare to a different period, it might be a lot. If you compare to this particular period, it's a small value. So these values are relative, and we always need to compare the values of this. And here is the plot for the second number. And you see it on the top right, on the top left, I'm sorry. You see the topic called Creature Rifle Plateau. That's the hunting topic. And so in the adventure novels, it has a probability of 0.38. And because of the comparison values in that heat map, we can see that this is a high value. This is unusually high. So the hunting topic is very important in the adventure novels and much less important in other novels. So again, in context, the number makes sense. And for the third one, this is another comparison. Here we have the frequencies of a number of high-frequency function words in 3 different authors. And in this case, we can see that the value for the word and, in Leblanc, the yellow line, is actually higher than in the other authors. So that tells us something as well. So for example, if we do authorship attribution, and we have a text that has a relatively high frequency of and, it would tell us that this text is slightly more likely to be by Leblanc than by the other 2 authors. But of course, it's only one piece of evidence. But again, in comparison, these values get meaning. And this is what Keyness is really all about. It's trying to compare values, trying to generate values that make sense in comparison and that help us compare texts. But let's look into Keyness a little bit more closely. So what is keyness or what is distinctiveness? Keyness is the established term in linguistics, in computational linguistics or corpus linguistics, but we also like the term distinctiveness because it underlines the comparative dimension and the fact that what we're looking for is words that are special and typical, characteristic, distinctive of a certain group of texts when compared to another group of texts. But the traditional definition of keyness is as follows, and it's purely quantitative, by Scott in 1997. A keyword is a word which occurs with unusual frequency in a document or corpus by comparison with a reference corpus. So his definition is purely quantitative. So unusual frequency, if the frequency is higher in one corpus compared to another corpus, then this word would be a keyword. evaluate a measure implementing that definition. It's impossible, because the measure is the definition. Because you would calculate the frequency, and if the frequency is unusual, then by definition, this is a keyword, because that's the definition. So the definition and the measure are so closely connected that you cannot evaluate one against the other. So in my opinion, we need a qualitative understanding of keyness, of words that are characteristic or typical of a certain group of texts when compared to another group of texts. We need a qualitative understanding of this notion, and then we can come up with quantitative measures that operationalize that concept, and we can check how well they do it. But if the definition and the measure are identical, there's no way to evaluate them. We need to tease them apart, and then we can check whether they match. And this is what we have been doing in this project. So the first publication on this subject is the one mentioned here, and it really tried to dive into this qualitative understanding of keyness. And we distinguished a number of possible, oppositions when talking about keyness or distinctiveness. And first of all, there's a logical versus a statistical sense. And we're still in this realm. So a perfectly purely logical sense of keyness would be to say that the feature is distinctive of corpus A if its presence in a document D, is a necessary and sufficient condition for D to belong to A and not to B. So if the word is there, the text belongs to a certain group. And if the word is missing, it doesn't belong there. That would be a perfectly logical, perfectly clear way of looking at keyness. Of course, that's not possible. And in language and literature, everything is always on a gradient. It's not binary. So it actually doesn't really work, I think. So we do need a statistical sense of distinctiveness. For example, in this way, a feature is distinctive of corpus A if it is true that the higher the keyness in document D, the higher the probability that D is an instance of A and not of B. So here, instead of a purely logical and binary sense, we're talking about more or less high frequency and more or less high probability. So the keyword becomes a possible indicator contributing some evidence to this idea that maybe that text belongs to a specific group. But that's just one way of looking at keyness. The other way is to ask whether keywords need to be salient, so we need to be able to perceive them, or we can be agnostic about seeing them or not, or perceiving them or not. So if keywords need to be salient, we would say a feature is distinctive if and only if it is noticed by readers for confirming or violating their expectations. So words that we notice are typical of a certain text, they could be keywords in that sense. But we could also say, no, this is not necessary. It is not necessary that people realize that the keywords are keywords. They can just be statistically distinctive without people noticing. So in that sense, we would say we are agnostic about the saliency. We could say the feature can be distinctive without being salient in the above mentioned sense. So that's a second possibility. And you already see that there's a space of possibilities opening with multiple dimensions and multiple possibilities. And then there's a third way of looking at keyness with a qualitative content or non-qualitative content. So if we say a keyword can only be a keyword if it has a qualitative content, if it has a qualitative, meaningful connection to the group of texts that it stands for, then we could say a feature is distinctive if and only if it expresses something like the aboutness or the stylistic character of a text or group of text. Meaning it has to be interpretable in some way. We have to be able to relate it to the group of text it stands for. And if we say no, that's not necessary, then we are in the realm of a keyword that has no qualitative content, and we could say it is key regardless of the qualitative content. In that sense, it could still be a keyword because it has discriminatory power. For example, it helps us separate text into one and the other category, even if we cannot interpret it, if it doesn't make any sense to us. That has no meaningful relationship to these categories that we can distinguish. Now this is just a little bit of the theory, but we will come back to elements of this theory in the course of the lecture. But what is important to me here is simply to say it is possible to have a more ambitious qualitative understanding of keyness than just saying keywords are more frequent in this. A keyword is more frequent. A keyword for one group of text is more frequent in that group of text than in another group of text. So it's not just about frequency. There can be we can try to give this notion some intellectual, semantic content in a way. And then we can try out measures that operationalize one or the other sense of this meaning. So before we go to the measures, and I will get there, a few words about the history of keyness in computational literary studies. It's not a very long history, but I do want to show that keyness has already played quite a substantial role in computational literary studies. So, the history of keyness in computational literary studies starts and revolves really around the proposal by John Burroughs of zeta. And this is the name of the measure that he proposed. For him, and this is the publication in which he proposed it. If you notice, this is barely 20 years ago, so it's relatively recent, a relatively recent proposal and a relatively recent development in computational literary studies. At the same time, almost 20 years, there has been some things have been going on, obviously. And John Burroughs is best known actually for his work in authorship attribution. So he proposed another measure called delta, which was used for authorship attribution. So for finding the true author of anonymous text or pseudonymous text. But he also introduced zeta in the same context in order to find words that are typical of authors that you would then use to narrow down the field of candidate authors and then apply delta on a smaller set of authors. But zeta has been quickly adapted also for other purposes than authorship attribution. It's a rather simple measure, and it is calculated as the differences of the document frequencies of a feature in two contrasting sets of documents. The documents are segments of full text. So document frequency basically just means, does the word appear in this document or not? So it's a sort of a binary frequency. It appears or it doesn't appear. And if you do this not on whole text, like long novels, where most words will appear once or multiple times, but if you do this on segments, shorter segments, maybe 5,000 words, and then you count in how many of these segments does this word occur, and you count these document frequencies as a proportion, that's the basis of this measure. And so you calculate the document frequency or the document frequency proportion in your target group of text and in your comparison group of text, and you just subtract them from each other. And that gives you a score, which is the zeta score. And it shows, so this is a measure that captures how evenly a word is distributed over a text. It can only have a high zeta value if it appears in many, many of the segments of your target corpus, and in very few of the segments in a comparison corpus. So that gives you a high zeta score. But if it appears a lot, many, many times in just one segment, that won't really show, that won't register, because it's a binary document frequency. It will only get a 1. Whether it appears once or multiple times, it only gets a 1. Anyways, I will show some applications of this in a second. So for Burroughs, he said it is a simple measure of an author's consistency in the use of each word. Yes, and this is why we call it dispersion measure, because dispersion is the technical term for measuring the regularity or the evenness of appearance of the word in a text. Yeah, this is still Burroughs in his authorship context, which I will illustrate here. So here, Craig and Kinney, two authors that have co-written a book on Shakespearean authorship attribution, they applied zeta to a corpus of early modern playwrights, among them Shakespeare. And what is plotted here are three groups of texts. First, the Shakespeare text, the gray squares. Those are Shakespeare texts. So those texts are all on the bottom right, because they have a high frequency for the words that are typical of Shakespeare, okay? That are overrepresented in Shakespeare, that Shakespeare uses consistently, I should say, because we're using zeta here. And on the y-axis, that's the words that the other authors use more consistently than Shakespeare. So the other texts, they are more on the left and to the top, because they use these words more. And you see that there's hardly any overlap. There's a little bit of overlap between, you know, the small black squares and the big gray squares. But hardly any overlap. So these features separate the two groups quite nicely. And then there are the round circles, the circles. And they are the text of interest. So the controversial or uncertain, the text of uncertain authorship. And we see that all of these circles are with the Shakespeare plays or Shakespeare segments, a little bit more to the area of overlap, so it's not entirely, you know, clear, but this is a strong signal that these texts are probably written by Shakespeare. It doesn't mean, you know, we can be certain or it's absolute, but it is one piece of evidence in that sense. I will not go into all of these references, obviously, but there has been quite a bit of work on zeta, including some rather harsh criticism by Lisby that I mentioned here, and responses by other authors, including Hoover, to these. But so zeta is, you know, alive and kicking, you could say, in the computational linguistics community. I would like to show, I think, two more examples of its use. So here it's a similar approach. We plot marker words and anti-marker words, so just the way we just did with Shakespeare. But here, the segments are by male and female authors. So the split is complete. So this is not all about authorship attribution. It's a different, let's say, it's an adaptation of this measure for completely different use. In this case, a comparison of two groups of authors by gender. Okay? And the three plots show three different time periods. And we can see that the amount of overlap in their use of the words is, you know, differs between the three time periods. So the overlap is bigger in the first period on the left. It's least in the middle period, the modernist period, and it goes closer again in the contemporary period. So what the authors conclude is that the separation of the writing styles by gender was strongest in the modernist period and became smaller again afterwards, which is an interesting finding in terms of what we know about, you know, growing consciousness of feminist or feminine writing that seems to go back again in the contemporary period, at least in this corpus and using this method. And the last one is from a study that I did myself some years ago on French plays, on French classical drama. And here, what you see here is a plot of plays, so they're different. Each dot is a play, and the position of each dot is depends on 50 of on the frequency of 50 zeta keywords. So keywords that we established using zeta, and then these 50 words are projected or placed in 50 dimensions. I here projected onto 2 dimensions using a technique of dimensionality reduction that simply allows us to summarize the data and show it in 2 dimensions. Because in 50 dimensions, we can visualize it. Or basically, we can imagine how it would look like. And the question here was, so the red dots are comedies, the blue dots are tragedies, and the green dots are tragicomedies. And the question was, you know, what is tragicomedy? Is it, you know, a special type of comedy? Or is it a special type of tragedy? Or is it something separate? You know, some third genre that, you know, that is either a mix or something completely different. And it turns out, at least according to this analysis, that tragicomedy is a special kind of tragedy. Because the green dots overlap mostly with the tragedy. So they're much more closely related in their vocabulary, in what makes them special, in their special vocabulary, their distinctive vocabulary. They're much more closely connected to tragedy than to comedy, and they're also not a separate group of texts, you know, somewhere in between or somewhere in the third place. So they overlap with tragedy and not with comedy, and they're also not in between. So that is sort of a quantitative answer to this, you know, mystery of the tragic comedy. before what we saw on gender, there was hundreds of novels as well. So more than we could read and more than we could keep the words in mind, we need statistical methods for this. And so zeta and Keyness measures in general, it's one way of doing the sort of comparisons and investigations into the differences and similarities of groups of texts. Now we come to the part that is really what we have done in the project in here together with this group of colleagues. And the starting point was something that we realized, and that's that there are many different measures of Keyness. It's not just zeta. Zeta is actually a rather marginal, unknown measure of Keyness. There are many other measures of Keyness that are much better known, and I'm actually wondering where on the list of this. It's here. So this is a list of some widely used measures of Keyness, and the interesting thing about them is that each of them is associated with a certain community. For example, in corpus linguistics, everybody uses log-likelihood ratio. That's the measure that's implemented in most of the tools, and that's what everybody uses. In information retrieval, so in the subfield of computer science, everyone uses TF-IDF. And if you ask them, what should I use if I'm interested in comparing two groups of text, they will say TF-IDF. If you ask them, if I want to normalize my frequencies, TF-IDF. This is like the standard method in that field. And they would never use log-likelihood ratio because it's, it has some drawbacks. But the corpus linguists would never use TF-IDF, at least not for this particular purpose, because it's not, usually used in their community. And then computational literary studies invented zeta, which nobody else uses. And so the question is, why is everybody using different measures? And how do they compare? And which one should I use in, with my particular corpus, in my particular situation, with my particular question? And so we need to evaluate these measures against each other, because every community will tell you that their measure is useful, and probably it is. But we're like an interdisciplinary field where it's not obvious which method we should use and from which field we should borrow. So our idea was to compare these measures. So we implemented them all in the same framework, and we evaluated them all in the same corpora. Because another thing that happens is that evaluations of these measures, even if someone compares 2 or 3 of these, they will always use just one corpus that is applicable and relevant to their community, but not to other communities. And the measures are implemented in each measure in one tool that the community uses. So if you want to compare them, you have to use one measure in one tool and another measure in another tool. And then when you get different results, you don't know why. Is it because of the measures? Or is it because of the way the tool maybe pre-processes the texts? Or maybe how it normalizes frequencies? Or how it uses stop words? So there are lots of factors that make it that you cannot really compare the results. So we also realized that we need to implement all of these measures in one tool. And that's what we did in this project. So we implemented them, and we designed corpora to test them, and then we did some evaluations. And I want to get to the evaluations now. And so we did 2 sorts of evaluations, quantitative and qualitative, because again, we think that we need to have a more rounded approach to this question in order to get a good picture of what this is really about and how these measures function. So the main corpus that we built for this purpose is a corpus of French contemporary fiction. So it's all novels, many of them, and you see here the covers that represent the different genres. So on the left, it's sentimental novels, love stories, okay? And it's easy to tell, I think, on the cover. The one next to it, the black one, is crime fiction, so detective novels and crime fiction. So it's very dark, and you can imagine that the person running away there is maybe either a detective or a criminal, and this is in Paris, it rains, the whole atmosphere is in that image. And then all the way to the right, the green one, that's science fiction. So, discovery of new worlds and strange creatures and space travel and all of that. And then the white one, is called Littérature Blanche in French, so white literature, and it comes from this collection because it has a white cover. for each of these, we collected examples from multiple decades. And so for each decade and each genre, we had 50 novels. So that makes 600 novels in total. And we're still working on digitizing more. We have actually 1,500 novels now. But this is the set, like 600 is the set that we used for these experiments. Actually, 320 in the first experiment and 600 in the second experiment that I will talk about in a minute. They are all under copyright, obviously. They're contemporary novels. So we were not able to publish the corpus as such, but we randomized the order of the words so that you cannot read them anymore. But you can still do statistical analysis on word frequencies. So these are actually published. The corpus is published, but you can't read it. You can just read it. But for some analysis, it's still useful. Anyways, to the evaluation task. You have the reference here below. That is the paper that we wrote about this first evaluation task. And the idea was that we designed a downstream classification task. So we had two steps in it. First, we extract the keywords. So we use a given measure of keyness and extract, let's say, 50 keywords. And then we use these keywords as features in a machine learning classification task. And we check how useful are these words for the classification task, for this distinction between genres. If it works well, if we get high accuracy on the classification task, then the words that we extracted must be features that are distinctive, that are discriminatory for the genres, right? And the measure must be useful. And if it's not, if the classification doesn't work well, and the classifier confuses the genres and makes many mistakes, then these features apparently are not really useful for this task, and so they are not good keywords. So it's a purely quantitative statistical way of evaluating this. And we do this because it's very difficult to evaluate keywords. Because, for a simple reason, because there's no gold standard. So usually, when you do a task like this, and you want to evaluate it, you're doing manual annotation to create a gold standard. For example, when you do name entity recognition, you want to have a system that finds the names of persons, of places, of organizations in the text. And you have an automated system that does it, and you want to know how good is it. So you need to annotate a part of your corpus by hand and be very sure this is really a person, and this is really an organization, and this is a place name. And you can do this because you can read the text bit by bit and say, oh yeah, I know this is a name. In this context, it's clear New York City is a name. Or in this context, it's clear Alain Delon is a person. But for keywords, you can't do that. Because a keyword is not a keyword for itself or in a limited context. It's a keyword because it appears with a certain frequency or dispersion or distribution in hundreds of novels. When you compare it to hundreds of other novels, nobody can keep that in their head. So there's no way to find the keywords by hand. And then to evaluate them, we need some other reference. And so the classification task is one way of having a sort of external test for the keywords. So anyways, we had 4 classifiers because we didn't know what classifier would be best. We used different numbers of keywords, just 10 keywords or 50 or more, even up to 5,000 keywords. We used segments of text, so we split the novels, which are very long, into many, many small segments, 5,000 word segments, because we think that when a person reads one of these novels, they know very quickly, is this a love story, or is this a crime fiction, or is it science fiction? If you read a few paragraphs, you usually know. And so we wanted to see, we wanted the test to be realistic. So we also give the classifier just a short segment. Okay? Then we did this, many times, tenfold cross-validation to get accuracy scores that would be a good summary of what is really going on, and to avoid chance up and down values to make this a little bit more reliable. And of course, we also calculated the baseline. So how well does the classifier work if we just give it random words instead of purposefully chosen keywords? And of course, we would expect the keywords to be better than the random words. If they're not better, then something really went wrong. But how much better than So first of all, we see that, so the x-axis, the horizontal axis, is how many features did we use, how many keywords did we use. Just 10 or all the way up to 5,000. Okay? And you can see that the more keywords we use, the better the performance gets. And that makes a lot of sense because if the classifier, the machine learning classifier, has more features to choose from, the performance will go up. But it's interesting to see that some of the measures, like these here, the blue one, and these two, they are very low with just a few keywords. And then, well, this one stays low, so this is not a good measure by any means. But these, they do go up after a while. With many features, they also get quite good. But others, like these here, and these is Burrow Zeta, and the variant of Burrow Zeta, they are very good from the start. So even with very few features, they have very good performance already. And now you could say, okay, but the computer can calculate many values. Why don't we just use a lot of words, and then the classification will always be good, and it doesn't matter which measure you use. So the whole evaluation of different measures is useless because if you use enough words, it doesn't matter. The problem is interpretability. So when we do this, we don't just want to classify text in categories. We know that with deep learning, with neural networks, we can do this very well because they learn very well the regularities, and they can weight each term to be most useful for this distinction. But what we want is we also want to understand what's happening, and we want to find a way of finding keywords that are meaningful and useful for classification. And that's only possible with a small number of words. Because even when you have very, very well understandable words that you can relate to, like detective fiction or love stories, if you have more than 100 of them, it gets really a lot of work to think about them and test them and control them. So it's an advantage to be able to work with a small set of keywords. So we're looking for measures that work well even with a small list of keywords. And for that, obviously or apparently, Zeta is really good. And so other measures of keyness that use the distribution of the words in the corpora or the dispersion of the words in the corpora are also quite good. But a measure like the blue line here, that is ratio of relative frequencies, so it just looks at the relative frequency in comparison, a bit like Scott actually, it's actually not very good. And also, to our surprise, the green one here and the orange one, these are the two measures that are very popular in corpus linguistics. And so they are also problematic, at least with a low number of keywords. They get better later, but they are not performing very well with a low number of keywords. Now, does that mean that they're useless? Not at all. I'm not saying that at all, because this is just one particular way of evaluating these measures. One that is purely aimed at the statistical performance and the discriminatory power for a classification task. And that's not, there are many other ways of using keywords. So in other contexts, other measures might be more useful. This one basically just shows the same trend. It shows the distribution of the performance for different measures on this classification task, here with just 10 keywords. And again, you can see that there's a group of measures that perform very well. And these are the two zetas. And another variant of eta that is also a dispersion-based measure. And actually TFIF very good as well. So we shouldn't throw that overboard just because it doesn't, it's not part of our habits anymore. Okay? But anyways, this is just one way of looking at this kind of evaluation. We thought, okay, now we know that these dispersion-based measures are good if you want to extract features that have high discriminatory power, that are useful in a classification task. But are they also meaningful? Can we relate them to love stories or to crime fiction or to science fiction? And for that reason, we also did a second kind of evaluation, which was a qualitative evaluation. And I will explain what I mean with the subgenre profiles and how this works. But first of all, why do we need also qualitative evaluation? So in the beginning, we talked about these different meanings of these different ways of understanding keyness. So whether it's agnostic and statistical, or whether it has to be salient or has to include the aboutness of these texts. And so different measures may be useful for different ways of understanding keenness, and different tests, different evaluations may test for different aspects of keenness. So the quantitative evaluation was a test for this like agnostic statistical sense of keenness. Are these words useful for distinguishing the groups of texts we're interested in? And we didn't even look at the keywords. I mean, we didn't. It plays no role. What are the keywords? You know, we just use them as features for classification tasks. So in that sense, we don't need to interpret them. But of course, we want to know, are they interpretable or not? How can we find interpretable words? And this is what the qualitative evaluation is for. So how can we do this? And so our approach, it's a bit tricky. And I'm not 100% certain that this is the best way to do it, but it's one way that we approached this problem. And the paper is not yet published, it's submitted and under review, so I hope it will, it will not be criticized too harshly, but we will see. But so you get a preview of this unpublished publication, which is at the same time maybe interesting to have this kind of preview, and at the same time it means this is not peer-reviewed confirmed research, so take it with a grain of salt. First of all, we said, okay, let's establish subgenre profiles. So because if you ask someone, what is detective fiction, they will give you one answer, and you ask another person, they will give you a different answer. So we have a sort of an intuition of what crime fiction is or what love stories are, but how can we, define this a little bit more clearly or precisely? So we read quite a bit of scholarly literature on these subgenres, and then we try to create systematic descriptions of them. So we distinguish the setting, so where does it take place, the characters, what are the typical characters, the recurring characters, the themes, the narrative form, and the language, the style or the register that we could find. And these were the categories that we tried to find information about from the scholarly literature, so that we could describe these subgenres, like detective and science fiction, along these lines. And I will give an example in a second to show you how it is. So then we have these like abstract descriptions, systematic, like structured descriptions of the subgenres. And we did these first and put them aside. And then we created lists of keywords for each subgenre using 3 different measures. Not all the 9 ones, just 3 very different ones to make things a little bit more manageable. We use these 3 measures, the likelihood ratio, zeta, and Welch, because they work in a very different way, statistically speaking, and because they perform best in their group for each of the groups that we saw in the earlier research. And then we brought these 2 sides together. So we took the keyword list and we matched it. We tried to match the words with the description of the subgenres. So for example, just one of many comparisons. We looked this is the example of the setting category for science fiction. So there's characters for science fiction, there's language for science fiction, and then there's also setting for detective, and for novel, for love stories, and all of that. So the summary of this description was to say that solitary settings are typical of French science fiction, for example, space, deserts, or the Arctic. The spaces are often vast and imaginative, and there's a vast range of different settings. Space, alternative universes, hallucinatory landscapes, the moon or Mars, so other planets. Okay, so this was what we got from the scholarly literature. We tried to condensate, a lot of the discussions into this very reductive, I admit, definition of space and science fiction. And then we looked at our list of keywords and said, okay, which of these words can we relate to that particular aspect of science fiction? And so for each measure, we had different words that we could relate to that. And on the right, or in the columns, you see the words that we found among 50 keywords, the top 50 keywords for each of these 3 measures. Those are the words that we found that relate calculated the inter-annotator agreement. So how well do people agree on these matchings? And it was actually quite low. So there's either it's a very difficult task, or this wasn't done perfectly well. So this is not very clear, and it's actually a little bit problematic to have such a low kappa score. But we have to accept what happened and present it honestly. And then the left half of the graph sort of expresses the general interpretability of the keyword lists that we got. So the higher the blue bar, the more words we could relate to the subgenre profile. So you see that for Zeta, this is very high, except for literary fiction. For Welsh, it's very high for two subgenres, but a bit lower for two other subgenres. And for the likelihood ratio, it's actually pretty low for all of them. So the general interpretability is highest for Zeta and Welsh, and low for the likelihood ratio. And then on the right side, so this is this is the summary. And the right side shows, so of the words that we could interpret, to what categories they belong. And this is actually a very mixed picture, and I'm not going to talk about in much detail. Just maybe as an example of how to read this graph. So if we look at Zeta and the sentimental genre, then we can see that different categories here play a role. For example, setting, language, and characters. Whereas for fiction, only thematic keywords are relevant, and the others have very small bars. So, but it's sort of inconclusive, to be honest. It's not very clear whether there's any systematic relationship that would make Zeta stronger on themes and Welsh better on characters or something. It's not that easy. It's a pretty mixed bag. And as I said, this is ongoing research. So this brings me to the end of the lecture, actually, to the conclusions. So first of all, what have we found out so far? How can we summarize this? In terms of the definition of keenness, I think we have shown that the keenness should not be defined only as unusual frequency. Other aspects like discriminatory power, salience, or loudness should also be taken into account when considering keenness as a concept. And we have also been able to show that you can establish a certain match or establish a certain understanding of keenness and a specific measure of keenness and try to establish what measure of keenness is associated with what understanding of keenness by doing evaluations. So we have seen actually that the dispersion-based measures are good both in the qualitative sense and in the quantitative sense. So the evaluation studies have shown that dispersion-based keenness measures show best performance in a subgenre classification task, especially when the number of features is small. Something that is actually desirable, so it is relevant. And also, we have been able to show that dispersion and distribution-based measures tend to select medium frequency words that are highly interpretable and fare well in a qualitative evaluation. So it's actually interesting that the dispersion-based measures are good in terms of discriminatory power and interpretability. And that was really interesting to us because when we first did the quantitative evaluation, we thought, oh, okay, these measures work well in this classification task, but maybe there's nothing we can do with these features. But it turns out they are both useful and interpretable. So that's really encouraging. And then with respect to Zeta, we can say that it is a fully competitive keenness measure and often preferable even to the likelihood ratio, at least in the context of computational literary studies, where we have specific sets of corpora. For example, we have very long novels that work differently from, let's say, newspaper articles or social media postings or customer reviews that are often, or newspapers that are often the object of study in corpus linguistics. So maybe it does depend on the materials that you are looking at as well. What is the best measure to look at? So properties, statistical properties that we understand very well because we designed them ourselves, we generated them ourselves, and then we can inject words with a given frequency or with a given frequency differential or with a given dispersion differential, and then test how sensitive the different measures are to these particular words. So where we know exactly, what do we give into the corpus, and then what do we see? What does the measure show us? So that's another way of understanding more precisely how the measures actually function and what they are sensitive to, what are their inherent statistical biases in a way, or properties. We also want to consider additional measures. I mean, 9 is nice, but they are always, we always come across other Keyness measures that are interesting. For example, Stefan Ries, who's an expert on dispersion, recently proposed a measure of dispersion that is purposefully designed in a way to exclude any influence from frequency. That's why he called it a DP, no frequency. And so we want to use that as well, as a pure dispersion-based measure, because Zeta is not purely dispersion-based, frequency still plays a role. Stefan Ebert recently at the DH conference in 2022 proposed a different measure that is more focused on the effect size than on the p-value of the likelihood ratio test. So that's also an interesting alternative. And then in the French tradition of textometry, which is a bit like computational literacy studies about the French tradition, there's a test that they call specificité, but that is, statistically speaking, based on the Fisher's exact test. And so we want to implement that as well, because because we work on French literature, it's also relevant to interact or to connect to the French community and the way the measures they use. So in order to be able to compare the performance of that measure also to our other measures. And the last thing that we're doing in the currently recently launched second part of the project in a way, that's called Beyond Words, we're going to move on to more complex features. Because at the moment, up to now, we have only looked at word forms, so very simple features, surface features. And so in this second phase of the project, we're going to look at multi-word expressions and at semantic features, using word embeddings and language models to do this keyness analysis on the semantic level instead of at the level of the words, to have a better abstraction. Because when we talk with, when we did annotation studies with the students of literature, and they read a piece, a small segment of text, and we asked them, so what is this, what is this from? Is it from a love story or is it from detective fiction? And how do you know? They usually said, I know it, but I couldn't pin it down to a single word. It's more the atmosphere, or it's more the theme, So we need more abstract features than just single words as well. And so this is what we're addressing in the current phase of the project. Yes, and the final thing that we want to think about is, now we have opened up the space of possibilities so much with all these different understandings of keyness and all these different measures. And that means we have a multidimensional space that we want to map onto each other. And that's actually makes everything very complicated. And so we need to find a way of handling this multidimensional approach and understand keyness not as just in one way, and then we need to find the perfect measure, and that's it, and we're done. But to say, okay, with different understandings and different measures, we can gain different perspectives on this comparison of text groups, of subgenres, of authors, of genders, and in this way continue